All right, so I wanted to walk you through the derivation of the law of sines. So first of all, let me point out that I've taken a triangle here, ABC, and I've divided it into two right triangles by dropping an altitude from vertex B down to side B. Um, what this does is it divides this triangle up into two right triangles, in which we're going to explore the relationships. So I'll be referring to that picture throughout this proof. Now, here's the picture again. It's two right triangles. Now, notice that when I drop the altitude, the only pieces of the original triangle that are still intact inside one of the two right triangles are little c and angle A, and little a and angle C. Angle B and side B both got divided up by that altitude. So what I'm going to do is I'm going to look at each of these right triangles and set up relationships with stuff I had in the original triangle along with this H here. So this is a right triangle here on the left. I have angle A and little c from the original triangle, and I have this H. So H is the opposite leg and C is the hypotenuse. So in that triangle, the sine of A would be H over C. And if I look at the right triangle on the right, for angle C and little a, which were in the original triangle, and this H, which is a shared side, H is the opposite side to angle C as well, and little a is the hypotenuse. So that means that the sine of big C is H over A. So you notice that both of these equations have an H in them. So what I'm going to do is get the H's in each of those equations by themselves. I'm going to multiply the top equation by little c and the bottom equation by little a, and that gives me this. Now, both of these things are equal to H, which is a shared side, so they're the same length. So I'm going to set those things equal to each other, and that equation looks like that. Now, I'm going to turn this into something that's a little more easily memorizable by dividing both sides by the little letters. So I'm going to divide both sides by little a and both sides by little c. And when I do that, that gives me this nice, pretty relationship here. That's basically a proportion of a sine of an angle to its opposite side being the same as a sine of another angle to its opposite side. Now, when you see the law of sines written in textbooks, most of the time it's written as a tripartite equality, meaning it has three parts. And it usually looks like this, that the sine of an angle and its opposite side is consistent throughout a triangle. Now, you could prove this sine of b over b by drawing an altitude from a different vertex, and that would prove the equality of the b stuff with either the a or the c stuff. And then by the transitive property, all three of those are the same. So these are the law of sines proportions, and this is the law of sine.